This is the second in a series of videos that I've decided to put together to describe and demonstrate some fun that I've been having using IoT, or the Internet of Things, to use electronics to add some animation and automation to some scenery that a friend of mine has built themed against Harry Potter in his basement. In the first video that I created, I went over the kind of the background and overview of the scenario and the goals that we had set out for ourselves for providing this animation, as well as the design for the modules that will be used to provide that automation. If you remember, I talked about 7 modules. There were 2 sensor modules and 5 actuator modules. In this video, I'm going to demonstrate the 2 sensors as well as 4 of the 5 actuator modules. The DMX module that I described in the first video, I had not done the research into that because I didn't have the hardware that I needed in order to be able to do so. So that's going to be covered in a later video. What I have laid out here are each of the 6 modules. They're laid on pieces of paper so that you can easily see them. And so I'll walk around and talk about each one. So starting here up in the front is the IR module. You'll see that out here, that's an IR sensor that will sense signals from, say, like from this remote control. That is an ESP8266 Arduino processor that receives that signal, and there's a power cord obviously that goes to it. I'll talk more about that in a bit. Over here on the right is the proximity sensor. It has a ultrasonic sensor that sends out a code and it bounces back to it, and it takes that and measures the time it takes for that signal to come back, and then it calculates a distance based upon that. Again, there's another ESP8266 Arduino here that is receives that signal and has the logic in it to calculate the distance. Up here on top we have an MP3 module. It has a speaker plugged into it. It actually has the controller itself as well as the audio processor separately. Next to it is a servo motor module, which is the servo motor. That little star you see on top is a star that rotates based upon the bottom value and the top value and the speed that we talked about in the last presentation. And there's its controller. And then over here, or its processor, I guess, not controller. I don't want to get that confused with the core controller that appears in the middle. So that's the module itself. This is the RGB module. I've actually hacked into an H801 unit, and so that I could burn the code into the processor that's in here to control that 5-meter LED strip. And then over here is a relay module, which again I've hacked into the code that it runs this SON-off relay so that I could burn my my own code onto it. And that is put in the middle of an extension cord that plugs in, and then this is a fan that's plugged into the other end of that extension cord that relay module is part of. If you remember from the previous presentation, there's also a controller, which is a Raspberry Pi, which I had drawn here in the middle. That Raspberry Pi is running upstairs under my desk, and I didn't want to disconnect it and bring it down here. But that's where it's run. And what's important to realize is that for each of these modules, the only wire leaving the white piece of paper is a power cord. Each of these is a power cord that plugs into this power strip, because they obviously all need power in order to function, but that's the only connectivity to them. Otherwise, every one of these ESP8266s talks wirelessly across and to my network and to the controller that's upstairs in the Raspberry Pi that orchestrates everything. The other thing I want you to notice is, in some of these it's a little hard to tell, but there is a red LED that's turned on. There's a red one there. There's a green one underneath it, but it is currently off. There's a red one there. You can see the red one there. There's actually 2 red ones there, a red one there, and then there's red ones in these, which are a little harder to see. But that is an indicator to say that these are stopped. If you remember the property and the events we talked about before, that indicates that these models are currently disabled, meaning they will not sense if I'm in front of this sensor. They will not react to any IR codes that it receives, and the actuators will not be triggered. They all have to be turned on in order for that to happen. The way that happens is through the UI, and that's what I have here. This is my iPad that's running it. I would normally run it on my phone, but I'm using my phone to record, so here it is on my iPad. And hopefully you can see this pretty well. There is a menu up here of scenes, right? If I bring this up, and you'll see that there's actually 3 scenes and an all scenes choice. And this allows me to control the devices in each scene. What I did forget to mention is here on the pool table, the way I have this set up is the 3 sensors to this side. So the relay module, the RGB module, and the IR sensor are part of the TNT store, the 12 fit and Taddings store. And so they're part of one scene. And then the modules to the right, the servo motor, the MP3 module, and the proximity sensor are all configured within the candy store scene. That doesn't mean that we couldn't have proximity sensors within the TNT store and IR sensors here and so on. That's all doable. If you remember from the properties we talked about, is what makes each of these modules identities unique is the scene that they're in and the name, the device name within that scene. So you can absolutely have multiple sensors in each scene or across different scenes. So in here you'll see we have the TNT store, we have the door, and we have the candy store. We're going to look at each of these, but at the top there's also an all scenes. And what that is, that's this UI that you're looking at here, which allows me to control all the devices across all the scenes. It gives me status indicators of each device, telling me each device that's here. Now granted, I have 6 on display here, but I have all the scenes configured for the various controllers that Adam and I have talked about. So when I turn these on, they won't all turn green because they're not all there to receive the event to turn on, but the ones that are will turn on. And then each scene has an LED capability to it. In here, as we talked about, only the TNT store does. I don't have one hooked up for Candy Store, but this would allow me to control the lighting if I wanted to across all the scenes together. All right. So one thing I'll do is, just to give you a sense of things, remember all these LEDs are red, right? So I'm going to touch Start All, and you'll see that some of the LEDs turn green on here, indicating their status. And if I go out here, and you'll see that the sensor is green. Oh, and then you hear I just triggered it because I stood in front of it. The servo motor, the MP3 is green. The lights are green. The relay is turned green, and the IR code sensor is turned green. So that allowed me to turn them all on. I'm going to switch scenes. Let's go back to, I'm trying to do this on my phone. Let's go to the candy store first. And here you'll see that I also have the indicators indicating what is on. And I'm going to stop all these for the moment so that we don't get everything happen. So I just turned off just the candy store. So now you'll see that the candy store devices are off, but the TNT store devices are on. And this LED strip, by the way, that lit up to the default color that we have set for that scene. So let me go back down here and we'll switch to the TNT store display. Oops, sorry, it chose the door. Doing this through my phone is a little tough. Okay, so you'll see the LEDs indicate which devices are enabled. I currently don't have an MP3 hooked up for this scene, nor do I have a proximity sensor hooked up. But then in here, there are sections, these blocks, that allow me to control each one. So here's the lighting module control section. There's, if there were a proximity sensor, I could control that there. This is the relay device here. This is the IR sensor. It's called spell because it would receive this spell from the magic wand. And then if there were an MP3 hooked up, that would be here. So let's see, what can we do first? So if let's take the relay, right? You'll see that the relay is turned on. That's what this indicates. The fan status is off, meaning that the relay is enabled to receive signal, but it's currently open, meaning it is not turned on. If I do this, you'll probably hear it. It's going to be hard for me to put it on the phone, but I'll pick the phone up and switch later. But if I touch this to turn it on, you should be able to hear and see that the fan is spinning, right? So that allowed me to prove and demonstrate that that module is functioning. I can also pulse that fan. So if I hit this button, you'll see it turns on, and I have it set to turn on for 5 seconds. I actually hit it twice by accident, sorry about that. So it stayed on for 10 seconds because I pulsed it twice, and then it shut off. So I wanted to demonstrate that. So that is controlling just that relay, right? That's uniquely adjusting that relay. Likewise, the lighting. So remember, the lighting started up to the default color. And here, let me just turn off the light, see if that helps. So now there's the default color. It's kind of a yellowish white color. Doesn't really show up great on the phone. But then within here, you can see this is a color wheel. Oh, it's kind of washed out. But I can come in here and I can touch a color. So if I touch, let's go to blue as an example, right? You'll see that it switched to blue, if you can tell that. If I go to red, I can switch to red. And now it has turned to red. If I were to turn on the fade, which is currently off, if I were to put the fade on, it would switch to fade. And I have the ability to adjust white from no white up to a bright white. So if I'll point this at this and I'll take the white, and you'll see it'll get brighter and brighter and brighter bright white. And then I can turn it back down. And if I want, let's see, I also have it set up so that I can type in a specific code if I want to go to if I know a specific hex value that I want to set, an RGB value. Oh shoot, cancel, I hit the wrong button. I can set the default color, which takes me back to the color that it was initially, and I can turn it off. So if I'll point this here and I'll hit the lights off button, and that turns it off. I'll turn it back to its default. So that allows, through the UI, to control those individual modules. Likewise, I could do the same thing with the candy store, and I won't go into those, but with the candy store I could adjust, I could trigger the servo motor, I could trigger the sound, and I could trigger the proximity sensor. I'll turn all those on in a minute, but I think you get the idea about how the testing works. Now what to do is to say, okay, this is the IR module, and you heard me talk about Node Red and how everything is programmed to work together. Let me just turn the light on again. All right, so now what I'm going to do is I'm going to trigger, I have a remote control here, and this sensor, the code that this is programmed to recognize is this middle OK button, or the enter button. None of these other buttons would have anything to happen. It's looking for the specific code for this enter button. And the Node Red logic is programmed to say, okay, when you receive that code, turn on the fan for 5 seconds, change the lighting in the scene for that duration, and then return back to normal. And the thought process we had about this was that this fan might be mounted to the floor, blowing up underneath the dress of a mannequin to make it flow, or behind it to make it flow as if it was a spirit or a ghost or something like that. All right, so I'm going to step back here a little bit. I have the remote in my hand. I'm going to press and listen and watch. So receiving that code, sent. It published an event back to the controller, up to my Raspberry Pi. The Pi received it, said, I received this code. I need to turn on the fan for 5 seconds. I need to change the lighting. If you saw it, it went to a bright white, and then return back to normal upon once that 5 seconds was up. So that's the way that happened. So now what I'm going to do is I'm going to come over here. Let's go to the candy store, and you saw this a little while ago. I'm going to start all the devices in the candy store, except I'm going to step aside. Now all these devices are on, right? And as you saw before, if someone walks up in front of the sensor module, you'll see that the servo motor turned a little bit, and the idea is that that would be mounted vertically under a table or something, and so that it would move the frog and make the frog hop. But at the same time, in sync with that, an MP3 sound was played to play the frog croak. And then it went back to normal. If I walk up again, somebody walks up in front of that sensor, it happens again. Right? And all of that is also controllable within here. So for example, the MP3, if I wanted to, I could change the MP3 and I could change the sound, and I'm going to play track 1. If I hit play, you'll notice it's playing a very different track than it played before. That's a magic spell track that I put in there, as opposed to the frog croaking. If I were to change that to be 2 and hit play, that plays the croak. That's what played before. There's a volume slider that allows me to control the volume. I can obviously turn it on or off. And I guess that's it. I can stop playing in the middle of a track playing, and again, I can configure or check for an update. The servo can be turned on or off. I can trigger the servo, so if I hit the trigger button, you'll see that the servo will rotate. It'll rotate only once, right? Because that's all it's meant to do, is to go up to its top, wait, pause for that period of time, and then return back down. So by putting all these together into multiple scenes, right now everything is on. I can walk up and I can trigger this by standing in front of it and trigger the frog to croak. But at the same time, trigger the fan to come on and cause something else to happen in the scene. So by taking these various modules and putting them in different combinations and configuring them within Node-RED to take specific actions, I could not only have these two happen, but you remember that there was an MP3 player that did not turn on here because I don't have one, but I could have one of these modules in the Tattings window to make a specific sound happen. I could have a relay turn something on over here to make a light flash or whatever happens. So you can put combinations of these together. The two sensors you can have in the same window. So as I walk up to one window, have the proximity sensor sense I'm there, but also with my wand, and the whole idea behind that is to take the IR emitter that's in a remote control and put that in the end of a wand, so that when you point the wand, obviously it would have to have a button on it to trigger the event, and that happens. The last thing to talk about, I talked about briefly, is the ability to do configuration. Each one of these devices, each one of these modules I loaded a web server on them. It's hard to believe, but there's a web server loaded on that little chip that I can directly get to from my iPad or my phone, and it will bring me into configuration settings where I can set, in this case for the proximity sensor, I can set how far away I want it to be before it triggers. For the IR sensor, I can tell it what code that I want it to look for. So it's not reprogramming the device, it's configuring it for how I want it to be used in a given scene. I can program how long, or I can set how long the delay should be, or how long the pulse should be on the relay. I can configure how many times this should croak, or how far that should spin, and how fast. So all that is configurable through that web UI. And then the last thing that I mentioned before, which I think is really important, was kind of cool for me from a maintenance standpoint, is check for update. Each of these modules has a button that I can go in and I can hit check for update, and it will connect to the controller upstairs to the Raspberry Pi if I've published a software update to it. If there isn't one there, it'll just come back and say nothing happened. But if there's a new piece of software that I published, it'll download that software to the device, load it onto the chip, and reset this chip so that it comes back up running that new software. So that's kind of the background about how all the modules work together. Right now they're all in, I guess you'd call them prototype mode. You can see they're kind of rough wired, right? Eventually they'd have to be wired down onto the PCB board to be able to run in the scene, but Adam and I will be working on trying to figure out how to put these into the scene, and we'll take it from there. So hope you found this interesting, and thanks. Take care.